What's up, everybody? This is Joe Begley, and today we're going to do the 7th Project Euler problem. So the challenge here is to find the 10,001st prime number. So how are we going to do that? So the first thing that we want to do is declare a function. This is nth, this is prime. And so this is a way to figure out whether or not a number is prime. Now let's think about it. A number that is prime is a number that's only divisible by itself and the number 1. So if we find any other factors for that number, it's therefore not prime. So let's take a look at this. We're going to say for var I is equal to 1, I less than n. So we'll set it equal to 2 because we're not too worried about 1, I plus plus. We're going to say if there is no remainder after we divide n by I, we are going to say that it is not prime. And then if we don't find anything, then it is prime. So let's say console.log is prime 5. This should return true. It does. Okay, now let's try 6. Should return false. Same with 60. All right, there we go. So this works, but the thing is this is grossly inefficient. And the reason being is that we have to loop through every number from 1 to n. There's a property with prime numbers, or there's a property with factors, where every factor has an opposite factor. So let's take the number 60 that we just did, for example. The factors of 60 are 1, 2, 3, and you know what? I don't know all the factors, so let's just do 6. So check this out. 1's opposite factor is 6, because 1 times 6 is 6. 2's opposite factor is 3. So to find the opposite factor, we just need to do the number divided by that factor. So let's take a number like 9, for example. The factors are 1, 3, and 9. 1's opposite factor is 9. 3's opposite factor is 3. So we only need to loop through to the square root of that number. We can always just go 1, 2 is not a factor, 3 is a factor, and then we have the opposite one. So we have all the factors there. When we do a number like 10, the square root of 10 is something a little over 3, so we're just going to say we're going to loop through 1 and 3. We go 1, okay, 2, and we divide 10 by 2 is 5 and 10. So what we're going to do here is we're just going to say I less than or equal to the square root of n. And it should still work. And it does. Let's test it with 60. And 61, which I believe is prime. And it is. Great. So now we just need to count how many primes we found, and once we found all those primes, return the last one that we find. So function nth prime, and we're going to declare a couple variables up top. We're going to say the number of primes that we found and the incrementer. And we're going to start the incrementer off at 2. So we're going to say while the count is less than n, so while we found, we're going to say we're going to keep executing this loop until we get to the nth prime. So we're going to say if is prime n, say count plus plus, and then every single time we loop through this, we're going to increment up 1. And so what's going to happen here is we're going to get to the nth prime, we're going to get to the nth prime, and then we're going to increment an extra time, so we're just going to return inc minus 1. Do it for 10,001. Let's see. We've hit an infinite loop. Oh, we need to do is prime inc of the incrementer. All right, here we go. That is the right answer, 104,743. So just to reiterate, we have a function that determines if a number is prime, and then we go through and we say while the count, which is the number of primes that we found, is less than n. So this is going to keep going. So we have something that counts the primes. Once we've reached the nth prime, this loop's going to stop executing. It says if a number is prime, we are going to increment the count, and then every single time we go through, we are going to increment the incrementer. So the incrementer is just the numbers that we are going to check to see if they're prime. The count is the number of prime numbers, and then at the end, we are going to return that number, which is just the incrementer minus 1. Because remember, we found the nth prime because the loop stopped executing, but we also incremented an extra time, so we just reduce it by 1, and we are good to go. Thank you.